For problem number 6, we're being asked to look at look for the inflection points. When does the function, the graph of the function, when does it change from being concave up to concave down? So I went ahead and I graphed the function. You're going to have to look at it closely because it's really subtle, but you can kind of see some movement in that graph, and that's that sine function that is causing that little wave. If you notice closely, I'm going to go ahead and exaggerate it a little bit, but that you can see there between 0 and pi, it's kind of concave up a little bit, and then from pi to 2 pi it looks a little bit concave down, and then again from 2 pi to 3 pi there's just that subtle kind of concavity. And so just through careful inspection, I can kind of guess that the points of inflection are pi and 2 pi. But let's just go ahead and solve that, find those using the derivative. So f prime of x, that's just going to be 8 minus 2 cosine x. And points of inflection, that occurs where the rates of change equals 0, or the second derivative equals 0. So take the second derivative again. Well, the derivative of cosine of x is negative sine x, so that just then becomes 2 times the sine of x. And we want to know, when does this guy equal 0? Well, the sine of x equals 0 at 0, pi, 2 pi, 3 pi, 4 pi. So every multiple of pi. And we're only looking for those values between 0 and 3 pi, exclusive, not including 0 and 3 pi. So that would eliminate 0, and that would eliminate 3 pi and anything bigger than 3 pi. So your final solutions, as far as those x values where these points of inflections occur, are at pi and at 2 pi.